Okay, so now we're going to go over the cardiovascular system, excuse me, and we're going to go specifically over blood products and that. Our next lecture is, and should be the final lecture, is going to be over blood vessels. So when we're talking about blood, basically what we're referring to is what's the function of the blood, what's it composed of. We're going to talk about, of that composition, it's basically made up of plasma, formed elements. Platelets are technically a portion of formed elements, but we'll do that as the other, and then talk about the homeostasis. So again, the body is constantly in chemical communication with the outside environment. So what that basically means is we're taking receptors from the outside and we're transitioning it inside. We're also absorbing nutrients through the linings, and then we're getting gas exchange and we're getting waste products that all have to be functions. So how does all this come about? Well, blood is a big aspect in all of those aspects. We kind of talked about the chemical interactions of it being a transport network. Well, this basically has our hormones, as we just talked about, are transported in here. Proteins, other communication devices are transported through the blood, and that communicates with the outside area. So blood vessels and system transport throughout the entire body, and that's a good communication network, how it stays intact. Our components of our cardiovascular system is the fluid that's circulating. That's our blood products. We have the pump, basically our heart, that keeps everything moving, and then the tubing, which is our blood vessels, arteries and veins to carry everything around. And really, this is also the transport system that brings our oxygen, our nutrients, our waste products, and then not only that, but it's like I said, it's our hormones, our steroids, communication devices, everything that's going to be involved in there. So our heart is technically one of the first organ systems to be developed. It keeps our circulation early stages of embryonic growth, and it doubles in size every week. So what's the function of the blood? Well, the blood basically is, again, it's kind of all those aspects we talked about. It is basically, it's in a fluid that comes through, and it does basically 5 major things. One, it transports gases, nutrients, hormones, waste products, all those throughout the system. It helps regulate our pH and the ion composition. It has a basically component of blood clotting, so it tries to maintain and take care of itself with injuries. It carries white blood cells around and other defense mechanisms against toxins and pathogens, and it also is a way that we help regulate our temperature. So our transport, as we talked about, again, it's going to carry all those around to each other. It gets gas exchanges at the most cellular levels. At that gas exchange, it gives oxygen and nutrients, but it also picks up all the waste products. Then it can take those off to the kidneys to be excreted. It's also carrying drugs and that to the liver, which help get detoxified. It's regulating our pH. Basically, it's through the kidneys as well as in the liver, where there's pretty much an exchange and balancing out of those areas down the loop of Henle, where there's that concentration gradient. It's getting rid of excessive alkalosis or excessive acidotic chemicals, and that's where it basically causes a balance. So it's keeping our pH, trying to do that, as well as it's working with our respiratory system to blow off CO2 and blow off waste products or slow down and such. So it's a big regulation of our pH and how it goes, and that's what carries everything around. Other aspects is once we get muscle contraction, as I talked about in there, in our anaerobic metabolism of energy produces lactic acid if we don't have enough oxygen to form the Krebs cycle. So we've got to get rid of those waste products. There's also a whole lymphatic system that goes along as well as the blood system that's part of this waste product and everything as well, which we'll get into later. We have the whole clotting cascade and ability to stop bleeding if we do have bleeding in the area. As far as if we get toxins and pathogens, viruses, our body basically has white blood cells and different antibodies that it carries around to basically fight off infections and disease process. And then the way that we distribute that fluid out to the skin, we're able to take heat away, or we're basically able to constrict the vessel's outside surface and maintain those heat into our core area. So how we restrict and increase flow of blood vessels can help us regulate our temperature. So what's it composed of? Okay, so big important factor here I do want you to know is what is the composition of blood? Well, 55% of blood is just plasma proteins product, and I'll go over that. And the other 45% is formed elements. Some people break that down into a couple different aspects where they go plasma is about 55%, which is built up of the proteins, fibrogen, globulins, albumins, everything like that. That part I'm not worried about. Whereas the other 45% of formed elements, realistically 44% they say is going to be red blood cells. This is a majority of it right here. Small percentage is white blood cells, and then about 1% is platelets. So realistically, if we looked from formed elements, that's your platelets, your white blood cells, and your red blood cells. So if I said, what's 3 components of blood? Well, I would say red blood cells are probably 44% of the area. Plasma is 55%, and 1% are these formed elements, which basically include platelets and white blood cells. So there's different ways, and the book's going to show different things, but if you put platelets and white blood cells as 1%, red blood cells is 44%, and plasma is 55%, that would be acceptable for me. Red blood cells, basically, they're these erythrocytes, and this is what transports our oxygen and carbon dioxide. So we also have white blood cells. Out of those formed white blood cells basically are part of our defense mechanisms. We'll get into this later when we deal with those, but they're made up of leukocytes. There's other aspects of getting into that I'm not going to get into here. I just want you to know that. And platelets, which basically help with our clotting cascade. As far as our whole blood, basically we carry between 5 to 6 liters in adult males, 4 to 5 liters in adult females. Now again, this is all up to change. Small men can carry 4 liters, large women can carry 6 liters. So it's an area, but I'd kind of go with the average of 5 to 6 for adults, as far as the range of how many liters we carry. So one of the procedures that we're going to know is blood draws. We need to get venous blood draw so that we can see exactly what's going on. We can tell different things in there, different injury sites. I'm in the middle of recording. What do you need? Yeah, I'll be here till probably 4. Okay. Okay, I will be here. All right. Thanks. Bye. So definitely something you want to know. We've got to be able to tell off different chemicals, what's going on in strokes, what's been going on in cardiac events for sure. So real easy way to get access to the blood. We can also tell it for like getting blood glucose measurements. Anywhere we can pop a small area and get some blood supply, important to know. If we need to get arterial gases, we need to go specifically in arterial. Our stuff we're going to be doing for EMS is going to be venous, works out just fine. As far as our plasma, again, it's made up of plasma proteins. It's made up of other solutes, and then the rest of it is basically water. That's, again, we're going to go over these in high detail later on, so I'm not going to go into the big composition of these right now. That'll be further once we're into class as far as going over these. So I'm just kind of skipping through here. You can kind of review that, but that's not going to be a huge aspect of the areas. The part of the clotting cascade, again, the liver is where we get most of our plasma synthesized, where that kind of comes in and does a lot of our filtering in those. Part of our formed elements, again, we talk about formed elements, and red blood cells are really about 99%. So you could even call red blood cells and formed elements as the white blood cells and the platelets too. Don't want to be too confusing on you, but that's kind of where they look at. So there's got to get the process of making blood. And this starts out early on as far as the development of building up these blood, and there's stem cells that do this, and we call pluripotent stem cells. I'm not going to go too much in this, but basically they'll divide to basically build all these areas from red blood cells to white blood cells to platelets, and each cells are going to be designed to develop into each. Where we get the hemopoiesis, or basically the development of blood, is the liver and the spleen. Liver basically is the creation of plasma. Red bone marrow is the production of red blood cells and white blood cells. And then the spleen is usually actually what collects and phagocytizes all the bad blood cells, and it helps break down the older blood cells as new blood cells build in. So spleen is more in the filtering side as opposed to the creation of side. So you get this hemocytoblastis that basically can develop into each of these areas as how it's reacted on, and whether it's going to become a red blood cell, whether it's going to become a platelet, whether it's going to become a white blood cell. Let's go see. I'm going to go hematocrit is basically the percentage of whole blood occupied. So basically, if we're doing a hematocrit, it's going to basically tell a little bit different in males versus females, but it also is the different of, are you an athlete and are you using a ton of red blood cells versus you're not as active and you have less red blood cells, but it's that combination of percentages that we went in. So I'm going to keep looking through here until I come across the next areas that we need to know. The structure is basically a biconcave disc. It's designed basically for passing through the cells. They will be able to change their shape and slide in and out through small vessels, and they have a high affinity for carrying oxygen and then also CO2 and getting that exchange. They can slip in really easy out of areas. The other thing aspirin does is it helps make them a little bit slipperier and works on the format of the hemoglobin so that they can slide into smaller spaces and squish and squeeze and slide past. It also makes the platelets slipperier too because it works on those. So it isn't a blood thinner, but it also decreases the ability to clot. So that's how aspirin works on there. I'm gonna keep skipping through this because for this being a quick review, I'm not needing to go over a lot of these stuff. Anemia, good thing to know, is basically when we have a low hematocrit, and we can get reduced levels of iron in that, and we have an ability to make red blood cells, and that's when we become anemic. It can happen for a variety of different ways that can bring it about, and that's about all I'm going to get to in this point. But when we get into the class more, we're going to go over a lot more detail of these. And again, our bodies are always exchanging and always rebuilding. It's always replacing itself as quickly as possible. So red blood cells, if they get damaged, if they get misshapen, those are taken up by the spleen. But also as blood cells get older, it gets taken up by the spleen and replaced by new blood cells. So it's a constant rebuilding of itself. And it's broken down and built back up on a constant cycle. So we're always growing. We're always replacing everything from there. The jaundice and bilirubin, basically talking about aspect of, when we're getting blood and we're coming areas, problems with the liver and problem with other formats I'm not going to get into at this point in time. Here's basically kind of a cycle of the blood and where it's coming through and the exchange through. You do not need to know any of this stuff for right now. This stuff will be important later on, but again, this lecture is about 218 slides. And I just want to go over the basic information right now. And that's about it on here. So we will be going over all these aspects of red blood cells, maturation, white blood cells, maturation. All these things will be important, but for right now, I'm not going to hold you accountable for any of these stuff. And for our class, we won't be doing that. Different aspects that start there. Erythropoietin is basically a hormone. Again, we talked about this in our endocrine cycle that actually causes the process of forming red blood cells. So it's basically released when we're anemic, we have low counts, or when we're sick or anything like that, and it's released to basically go to the red bone marrow, and the bones is where we build it up and cause that area. It stimulates the erythroblasts and then starts getting an increase in red blood cells. So we keep building those up. And you can see exactly from the area where it's coming in and where it acts to. So that's about all I need you to know is erythropoietin is basically that it starts the process. As far as red blood cells, basically we have different blood types that are out there. And then not only besides the blood types, we have different antigens, or what we call surface antigens. So we talk about the different type of blood types. Well, we have type A, type B, and type O, and then combinations with there. And then we have an RH factor, what we call a Rhesus factor, and we're either positive or negative. So those are the different ways we talk about blood typing. So this is very important for you to know. If we get a blood type, type A, it has the type A antigen only. A type B has the B antigen only. A type AB has both A and B antigen. And type O has neither antigen A or antigen B. So we talk about the universal donor and the universal acceptor that's out there. So what we're looking at is a type A has the surface antigens of a type A, antigen on B. And again, these are just represented. A and B has a combination of both, and type O has none of those. About 46% of the population is type O, and only 4% is AB. So a smaller concentration, larger concentration is A. Again, not that important to know, but kind of know where it's at. The other aspect onto the blood is this RH factor or Rhesus factor antigen. So if you have the antigen, you're RH positive. If you don't, you're RH negative. And that's another factor we do when we go blood typing, because again, if we have interacting antigens, they can actually fight each other out, and that comes really important, especially when we're talking about mom and baby, and how it's going to react when those bloods come in and how those antibiotics react. So we'll go over that in more detail later, but basically what I want you to know here is type A contains blood contains circulating anti-B antibodies. So if there's any type B surface antigens, it will actually attack those. Same as type B blood contains anti-A antibodies. So you can't give type A a type B blood, and you can't give type B a type A blood, because they will interact and they will fight each other off, and it doesn't work. So type AB blood lacks both A and anti-B opposites. So a type AB is actually the universal acceptor. It can accept type A, it can accept type B, and it can accept type O. Where type O contains both anti-A and anti-B antibodies on it. So it is a universal donor. And how we have to type and cross-match determines on what blood they can get. So if you're type O, you're going to be one of the biggest people they're going to be asking for to donate blood. Because if you get these antibodies that basically attack each other and coagulate, it's kind of a bad thing, bad process. We're not getting the normal flow. So you won't want these clumping together and hemolyzing and creating fragments in other areas and blocking things and plugging and basically causing clots everywhere. So that's why you have to make sure that you are typing, cross-matching, and getting everything set. Someone with a RH negative, they don't contain an anti-RH. So the example here kind of talked about in normal pregnancy, where you have an RH negative mother carries an RH positive fetus. You can actually get that exposure of mom's blood and baby's blood coming back can cause clotting factors and binding together. So you have to be really careful with those, and those are emergency type situations. White blood cells, again, all I really want you to know from there is that they're the basically defense mechanisms, and they try and go out and after infections, they remove toxics, they waste damaged tissues. They're also part of the healing process. Anytime a tissue is damaged and there's bleeding and there's clotting, white blood cells come back in to repair that. That's about the most. We're going to get into all the specific types of white blood cells, and we're going to get into other aspects, but for now, that's the biggest thing I want you to know. They are made up of neutrophils, eosinophils, monocytes, phagocytes, different other components in there, but I don't need you to know except for anything that right now is that they are basically our defense mechanism for fighting infections. And I'm going to be skipping through this for right now because, again, we have a ton of lectures to still get through. but all different aspects from here, and I'm not going to hold you for this testing period. Again, it'll be something we'll talk about later when we get into the paramedic class in detail. This is just a overview. There are different type of cancers that can come out, especially dealing with the blood. And anytime we're getting cancers in the blood, we call them basically leukemias, usually referring to the lymphocytes in that. That's all I'm going to get into here. There's white blood cell formation as there's red blood cells, and each hematoblysis will basically form into a stem cell and produce whichever type of cell we were trying to get, whether it's an eosinophil, a basophil, a neutrophil. There's different types of T cells that are out there. There's T cells and B cells, which again are more for the antibiotic side, fighting off diseases and that, and we'll talk about those more later. When we're dealing with platelets, they're basically just components of the clotting system. They're one of the biggest things that first identifies. They're floating out constantly. Like I said, it's 1%, roughly about 1% of the blood supply. They're continuously circulating. We have to have a lot of them out flowing. You see 150 to 500,000 in each microliter of blood, because that's out there, and it detects if there's an injury, and it starts the clarity factor, because once we lose blood, unless you can replace it with blood, I can replace all your fluid, all your blood with fluid, but it doesn't transport oxygen. So it's very important to be able to contain those. So we have to have a lot. So if you have a low platelet count, which they refer to as thrombocytopenia, it makes it harder to basically clot, and you can bleed out and have a lot of problems. Same type of thing can happen when you have blood thinners in other areas. It keeps you from your ability to clot. So our body's always got to stay in a process of homeostasis, always rebuilding. Anytime we have this area, we're getting a vascular phase, a platelet phase, and a coagulation phase are the three areas it comes through. Our vascular phase is basically building our blood vessels up, keeping our diameter, keeping the area tighter to decrease the amount of flow. So we see our arterioles will constrict and try and shut down the amount of blood flow that can come. And then when that comes down, it also pulls the cells in a lot easier, the squamous cells. They become stickier as they're closed and clotted down together, and they try and occlude there. The platelets then notice the injury. Those will start laying down a matrix, and it works with collagen and other fibers to basically form a matrix across the area and build up a clot. And then it forms this little plug around the wall, trying to stop any bleeding or any blood supply getting through. And then it coagulates, as basically as those bloods start clotting together, they start basically fusing and solidifying the area. There's a clotting cascade of several steps and factors that need to be involved in that. But as it lays down this matrix, the blood supplies will catch to it, and they'll just clot and form a hard layer until that area then is stopped bleeding, letting any blood out there, and then your white blood cells and other plasma proteins come in, and those will help build new blood cells around the area. So I'm not going to get into the clotting cascade at this process. We will get into that more extensively later. There is a big process in intrinsic and extrinsic pathways. There's different factors that can, if we have loss of, that basically make us hemophiliacs, Christmas disease, lots of different things up there that can stop this process. And here's just a quick aspect of the clotting cascade and all the hormones, factors, everything that's involved with it. So it's a quite extensive process, which we'll go over later. But for right now, we don't need to worry too much about this. And then once the clot's done, the body basically breaks that clot back down and wants to break it up as quickly as possible into small pieces so those clots don't go into small arteries, arterioles, venules, and block off area and block off flow. So we have to be very careful about that. Anytime we do have injuries and those clots break free, it just makes us more susceptible for other type of injuries. So big things, again, I want you to know is describing the components, the percentages, what's blood, what's plasma, what's platelets / formed elements, which is the white blood cells. Kind of understanding where blood is made, its main origin, where it comes through, And that's about it for today. Appreciate your time.